And I am here with Justin Drake, which already answers the question of who he is. But Justin, nice to see you. Please tell me a bit about what you work on.
Yeah, so nowadays I work on two main projects. One is Ethproofs. The idea here is to snarkify the L1 EVM so that the validators can verify snarks, proving the validity of the block so that they don't have to re-execute them. That allows us to dramatically increase the gas limit without having to worry about decentralization. So the goal is to get both scale and decentralization. So that's project number one. Project number two is all about securing the foundations of Ethereum for the long term. And there's this project called the Beam Chain, which is trying to take the latest and greatest ideas from research and do some of the upgrades that will come in the longer term, like post-quantum security, advance the research and development, and help with the coordination of the teams that will be required to pull off such a big upgrade.
Because you mentioned the Beam Chain and zk, I'm curious just generally what it is you're excited about in terms of zk and its impact on Ethereum.
Yeah, so you're right that zk is kind of a thread within these two projects. On the first one, increasing the gas limit, one of the really exciting developments recently has been real-time proving. It's this idea that we can prove heavy workloads, like proving the validity of a whole Ethereum block in real time, meaning within one Ethereum slot, which is 12 seconds. And just a few weeks ago, I would have told you 0 teams have achieved this. But now we have 4 teams that have achieved it, which is really, really amazing. So we have Succinct, Risk0, Airbender from zk Sync, and just at this conference, we had Zisk, the team that spun out of Polygon, that also announced real-time proving. Yeah, if you go to ethproofs.org, we're trying to build the L2 beat of zkVMs, and every week we're going to be adding one more zkVM. I have this tracker with 30 zkVMs, and so the space is maturing extremely quickly, and things will move very, very fast. Now, on the Beam Chain, one of the things that we're doing is the post-quantum signatures, moving away from BLS, which is not post-quantum secure. And the strategy here is to have hash-based signatures and to aggregate those using a snark. And here we have amazing performance. We can aggregate over 1,000 signatures per second. Signatures are very, very small for post-quantum signatures, on the order of 3 kilobytes. They're very fast to sign, very easy to verify. Everything's great there. So very exciting research for the longer term, and also very exciting engineering for the next 6, 12, 18 months as we dramatically scale the L1 gas limit.
2 questions just. The first is, why is it important to scale the gas limit? And the second is, why is post-quantum security something we should worry about?
Let me take the second one first. One of the things that has been discussed in popular science is the notion of quantum computing, the possibility that those could break the cryptography that we have. So whether it's ECDSA signatures that are based on elliptic curves, or things like BLS that are based on something even more fancy called like pairings, those just break once the quantum computers are sufficiently advanced. Now, what does sufficiently advanced mean? It's a very subtle thing, but long story short, you need to look at the number of qubits and those qubits having a high enough quality. If you looked at the state of the art of algorithms that could break the cryptography, last year or 2 years ago, it was on the order of 10 million physical qubits. But what has happened recently is that there's been a couple of papers that bring that number down. So earlier this year, we had a paper bringing it down to just 1 million qubits, and now it's only 400,000 physical qubits. So the algorithms are improving, and then slowly, exponentially, but still, because we're at the very early days, slowly we have quantum computers that, on the order of hundreds of qubits. So we're still several orders of magnitude away. It's going to take a long time, possibly, a decade, maybe more, maybe a bit less. But it's a very long process to do the research, but also to coordinate with all of the validator operators to do the upgrade. So it's good to start early. And it's also the foundation for what we're calling the Beam Chain, which is this very big upgrade that not only updates the core of voting, which is doing these attestations with signatures, but also around it, pushing all of the innovations that have been in research mode. So, for example, there's a tester proposer separation that will significantly simplify the job of being a validator. And there's all sorts of small improvements like making the exit queues faster so that you can withdraw your ETH faster. At the beginning of this week, we had a Beam Day, where we discussed a lot of these improvements. One of them is to have faster finality. So we talk about 3SF, 3-slot finality. That we also want to dramatically reduce the slot duration. So ideally set the slot duration based on speed of light considerations. And so there's this new meme, SOL, speed of light slots, not Solana. And yeah, all sorts of other upgrades that are related to the Beam chain. The vision that we have for Ethereum is to scale horizontally, right? Because a single virtual machine instance can only scale vertically so far, right? So some projects out there are trying to push the limits of the EVM and can reach a gigagas per second, but there isn't that much room to go further. And unfortunately, a gigagas per second is only 10,000 transactions per second, which is not enough for the whole world. It's on the order of 0.1 transactions per day per human. So instead, the vision is to scale horizontally and get to something closer to 10 million transactions per second, which is 100 transactions per day per human. But in order to have this horizontal scalability, we kind of need a hub in the hub and spoke model, one that is powerful enough to handle all of the spokes. And initially, one of the most basic services that we were trying to cater for was this notion of settlement, where you post the state roots and you post the proofs, and you have either snark proofs that get verified immediately or optimistic proofs that can be challenged. As we kind of saw the space evolve, we realized that there were more and more services that the L1 had to provide for its L2s. It needed to be a liquidity hub. It needs to be a place where bridging and composability happens. It's a place where assets get minted so that if there's an issue with the L2s, they can force exit back into the L1. And so we're trying to have a strong L1 kind of flexing its economic muscles, and that should also increase the incentives for the L2s to compose in a more unified fashion with the L1. Because what's happening today is that each L2 to a large extent is an independent silo, and that breaks down to an extent the network effects of Ethereum as a whole. So there's technological progress to speed up the speed of proving so that we can have real-time proving. And when you combine that with shared sequencing, things like base sequencing, then you start to unlock superpowers that give Ethereum as a whole more network effects.
You just mentioned base sequencing and base rollups, and I believe you actually introduced this term about a year or two ago. For somebody who has introductory knowledge, how would you explain base sequencing and base rollups and why it's something that a lot of people care about right now?
Yeah, so base sequencing means that you are using the sequencing of the base layer, which in the case of an Ethereum L2 would be Ethereum L1. So the way that Ethereum L1 sequences its transactions is by enrolling its validators that propose blocks every slot. So a base rollup is one that uses the same set of validators for the sequencing. And one of the advantages here is that out of the box you have a decentralized sequencer, something that very, very, very few L2s have been able to achieve so far. They're mostly leveraging centralized sequencers. But in addition to the robustness and decentralization that you also get more composability with the L1. And the ideal outcome is that when combined with real-time proving, you get this synchronous composability. And the litmus test for synchronous composability is flash loans. So if you're able, in a single block, to start a flash loan on the L1, for example, send it to the L2, do a bunch of arbitrage in the L2, send the funds back, and then close the flash loan, then you can do everything else. And the way that Ethereum has grown so far is in this synchronous model. That's how Solidity is, the programming paradigm for Solidity. That's why we're seeing applications break down at the boundaries, because we don't have the tools to build asynchronous applications. Not only are they kind of fundamentally less powerful, but they're also much, much harder to build. So the idea is to simplify the DevX to the maximum extent we can, but also give the full power of synchronous composability for applications that require it.
Justin, I'm going to ask you the question that I've been asking everybody this week. Simple question. Why Ethereum?
So I'm a kind of an old school guy. I've been in the blockchain space for 10 years, and one of the words that was used, even 10 years ago, is disintermediation, right? The idea that we can do a lot of activities between humans without intermediaries, like more in a peer-to-peer fashion. And when you look back into like all of the actions that we take that require trust, often there's like some sort of a company, or actually more often than not multiple companies in between. So I think a good illustration of this is marketplaces. So I ride an Uber, like really it's an individual just driving his car and me as an individual riding his car. Like, why do we need so many intermediaries in between that will handle the payments and the insurance and the reputation and the identity and all of that stuff? And so the way that I think about Ethereum is that it's an opportunity to rebuild these traditional services that use intermediaries as trusted agents, and instead have smart contracts be the trusted agents, be the counterparties. And because you're interacting with code, you ultimately end up with a much more efficient and composable system. So one of the things that people kind of have a hard time understanding is that these intermediaries are not only expensive because they'll take a cut. So for example, in Uber might take a 30% cut on the driver. That's not something that you can see as a user, but it is something you can see as a driver. Not only do they take this massive cut, but they are also preventing further innovation, right? They will guard their database of drivers and riders. This is proprietary stuff, and it's not an open network that people can tap into and build services on top. In the Ethereum world, because your counterparties are smart contracts that are like fully transparent, you also have this notion of permissionless innovation. And in my opinion, the lack of permissionless innovation is not a 30% cost on society. It's more like a 90% cost, right? We could be living in the meme of the sci-fi society if we had this and that. Well,
Society if.
I think if Ethereum takes on, we could imagine this sci-fi society where entrepreneurship is as vibrant as it was for the early days of the internet, but for trusted services, not just for communication services.
Beautiful. You basically answered this already, but maybe a more personal slant to that would be what makes Ethereum special beyond the technology?
Right. I mean, underneath the technology, the L1, we have the layer 0, which is the community. And for me, that is what makes me tick, especially at conferences like these, where I'm kind of meeting people all of the time. In the last few days, I met a lot of the zkVM founders in person that I hadn't met before. So, for example, Mo from Brevis, he's working on this Pico zkVM. I also spent a lot of time with Jordi from Zisk, and these are just like fantastic people that are constantly sharing alpha and are willing to collaborate, and it just gives you this energy. And one of the things I can say about EthCC is that the density of high quality people has been extremely high. It's kind of these bear market vibes where only the high quality people stay. So it's a good thing, and I think hopefully EthCC kind of marks an inflection point for the community. And I feel that with in the last few weeks, like things have been really good from a sentiment standpoint for Ethereum. And I'm hoping that the rest of the year is going to be extremely exciting as well.
I completely agree. Justin, thank you so much for your time. I know you've had a busy conference, and I think a lot of people will be excited to hear your opinions. So thanks again.
Absolutely. Thanks for having me.